All right, welcome everybody. So we're really excited because we have 4 great speakers today to take part in our sort of semi-annual lightning talk. As always, I'd like to acknowledge NumFocus for sponsoring this event, TD Ameritrade for offering up this venue, and obviously Midas at the University of Michigan for the food that you are enjoying here. Important points for people who are new here. First thing is emergency exits. There's one right over here and one right out to the doors that you entered through on your right. We're always soliciting for speakers, although this year we've been pretty lucky. We're booked out to about November right now. So we're doing pretty well. But always give us feedback. I got some feedback about food earlier, which I love, right? Also, check out our GitHub page. So if anything that we share here, the slides get posted as well, unless there are quick questions. Actually, for today's lightning talk, let's hold the questions to the end. So there's supposed to be about 7 minutes or so lightning talk. So hold your questions to the end. You'll have enough time. And please remember that you're in a borrowed space, so do clean up after yourselves. The trash is over by where the garbage cans are over by where the food is. I'd like to read our PyData Code of Conduct. PyData is dedicated to providing a harassment-free meeting experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, or religion. We do not tolerate harassment of meeting participants in any form. All communication should be appropriate for a professional audience, including people of many different backgrounds. Sexual language and imagery is not appropriate for any of our Meetup events. Be kind to others. Do not insult or put down other attendees. Behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for PyData. Attendees violating these rules may be asked to leave the Meetup at the sole discretion of the Meetup organizers. But overall, thank you for making this a inviting experience for everybody. So a quick icebreaker. So we're going to allude to who we have for our talk next month with this icebreaker. So please turn to either somebody on your left or on your right, introduce yourself, and tell them if you use NumPy, SciPy, or what's that? Go ahead. So I use both NumPy and SciPy, but it's part of the sort of Python data science stack for numerical computing. So the reason why I asked this is because our speaker next month is the creator of NumPy and SciPy. What do you typically use? What do you for your analysis?
I just look at charts, but I'm basically using a program written by a mechanical engineer that kind of guarantees you make money no matter how your stock goes. If it goes up, you make money. If it goes down, you make money.
And what language is that program?
It's from the 1980s, so you have to use basic.
Oh, okay.
I can't use it on my. I gotta have them run the XP.
I see. Cool. All right. Thank you. We're back. Thank you. So as always, hopefully you have met somebody new that you haven't chatted with before. This month's data science. This is not really that big of a news, but people who are doing deep learning, Cafe 2 has now been integrated into PyTorch. So if you have a Cafe 2 pull request, that actually goes into PyTorch now. It depends on your usage. From what I've heard, Cafe is better for developers. If you're developing deep learning models and you want to deploy them to iOS, Android, it's really good for that. Versus in PyTorch, it really allows you to build your models quickly and experiment. As well, TD Ameritrade is hiring, so if you want to check out our jobs page, jobs.tdameritrade.com, and also chat with Logan Ahlstrom, who's standing right up over here. His team is hiring a data scientist as well as a data analyst. So please reach out to him. Also, an announcement that there's a new meetup in town with Doug Lance over here. So he's running the Michigan Python meetup group. So do sign up and check it out. There's a lot of potential synergies between our two groups. And as I spoke about earlier, why I asked about NumPy SciPy is because next month we have Travis Oliphant, who is, I guess, the creator of NumPy and principal or original author of the SciPy package. He's going to be here next month talking about XND, a cross-language set of libraries for general typed containers. So I think that will be a great talk with Travis. So with that, we welcome our first speaker, and this is William Murphy.
Right.
And he's going to be talking about projection software for DJIA and all other stocks and commodities. Okay, your 7 minutes starts now.
Okay. In the 1960s, an aerospace engineer named James Marshall Hurst got interested in the market. He used Fourier analysis and a comb of digital filters to break down the data into its basic building blocks. He figured out how they went together and came up with a mathematical and conceptual model that explains every movement of all stocks, all commodities, financial futures, index, and there is absolute proof of what he found is true. And here is, my computer won't give us very many charts, but he says there's a,
you can take this out.
He says that all stocks and commodities have cycles in them, or waves. So if you will look here, we can say this is day 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and kind of 6. So there's a 6-day working within an 18-day cycle, working within a bigger, probably a 36-day cycle, and on until, he came up with a model that explains all this and how they go together. The trouble is, there's no way to get to the end of the data. If I was analyzing this mathematically, I would be, back here. That's where the end of the mathematical evaluation would end. So I can't get to the end of the data. So I've been trying to rack my brains for 25 years, because this thing is worth $100 billion, maybe $1 trillion, I don't know, because every stock does this. Now, I don't know if we can get another stock up, but we had another one. Let's see what this is. Here's another one. Oh, shit.
Scroll down a little bit. It's just
Yeah,
down.
okay, yeah, I see.
Yeah, just push down. Yeah.
See, the only difference between stocks is the trend. They still will have a little 6-day. You see a little 6-day, another 6-day, 6-day, 6, working within a bigger one. And all stocks, all commodities, all indexes have the same thing. And so that it gives you the possibility to understand what's going on and to be able to predict it. Because it will tell you ahead of time, the market will tell you ahead of time what it's going to do. It'll give you hints. It won't tell you exactly, but it gives you enough. So when you think of like Google, it may have 100 options, call options, for one, for April the 25th. It'll have 100 or 50 to 100 call options and 50 to 100 put options, which you can play. Just one, and that's just one thing. Then you got a May, June. So just that one stock, and when you think if Google goes up 2%, you'll get maybe 5,000% movement in one of those options. So being able to do that,
A little bit lower.
too close. So it gives you unlimited possibilities. And it's taken me, like I say, I've been fighting this for 25 years. It's crazy. I'm almost 84 years old, and I'm going to kick the bucket shortly. And this knowledge is going to be lost. Because nobody believes me. Nobody will look at the data. And it's crazy. Yeah. can't see. I don't know if we can find any other ones. No, it's mostly. But all of these, if you look, here's one, there's another one. I don't know what this one is, but okay. This is a compact computer, COMP, whatever, it doesn't matter. It's still got the waves working within bigger waves. See, a bigger wave, bigger wave, bigger wave, working with a whole bigger wave. This is unbelievable. Now, the problem is, like I say, how do you overcome it? Mathematically, you can't get to the end of the data, but you can get I've thought of making a projection model. Do it to an ideal sine wave, summation wave, and then counting these off and switching it until it does actually fit this. And then you can then project. But it's tough because for trying to do it in your mind, you got to think of, well, it's 27 days along and a 35-day going down. Well, this is 16 days along and a 47 days going up. And, it would drive you crazy. And you might be able to do it with a group, but one person, it would be really tough. Like I say, I have cards here if anybody's interested. It's crazy that I'm going to, kick the bucket one of these days and all this information is gone. Because there's nobody else in the world that knows what I know. Because have you heard of any of these mutual funds making 500 or 1,000% a year? No, it's possible with this. And there's absolute proof. I've got 50 different stock charts. They're all the same, period.
Yep, that's perfect.
Okay.
That was right on time. So were there any questions? Yes.
Yeah. So do you, now this would be, I guess, technical analysis. Do you combine fundamental analysis, such as, so you got weather patterns?
No, weather patterns, no.
Okay.
No, it's just fundamental to know, it's probably good to know if you're doing like a healthcare company or something where if they get lose on their
loss on their drug.
The drug goes, they can't use it.
Gets denied.
Yeah, because I've seen, there was one company that was trading at $47 and it opened the next morning at $27. And I always thought that there would be an indication that the insiders would know and would be dumping it and then it would crash. Well, it's not true because it was going fine, doing all its thing, and then it crashed. But see, even with something like that, you can have out of money puts, which would save you. Even if you're doing this and it crashes, you can make more money on that out of, 10 out of or 20 puts. It maybe cost you $2 or $5. You make $10,000 on them. If you lose $5,000 up here on the calls. But so there's no way, if you do it right, understand it, and project correctly, it's unbelievable.
Great. Let's thank William again. So up next we have Chris Gates, who will be talking to us about Snakemake for data analysis.
So thanks, Sean. Thank you. How many people here have heard of Snakemake? Let's see, show of hands. A couple people. A couple people that I know. Okay. How many people here are using Snakemake? Okay, it was a proper subset, so that's good. So let me start by telling you why I use Snakemake. So I'm the lead software engineer at the University of Michigan Bioinformatic Core. I work with about 10 other data analysts, and we try to help biologists identify and interpret patterns in DNA. And in practice, what that means is we take a large amount of genomic input data, and then we run them through a chain of bioinformatic tools to try to make sense of them. And often we automate that chain of bioinformatic tools into a process called a scientific data workflow. Now, over the last few years, we've been using Snakemake more and more because Snakemake is a framework that makes it easier to build and execute data workflows. So before we jump into Snakemake, I want to consider a traditional data workflow, and I could dazzle you with a really cool arcane bioinformatic workflow, but we're going to keep it really simple right now. And all we're going to do is we're going to transform a raw chicken into fried chicken. And we're going to do that very simply with a bash script. This bash script has 3 important steps. I marinate the chicken in the buttermilk, I bread the chicken, and then I fry the chicken. It's very simple, and as a workflow, there's one input, which is the raw chicken, and there's one output, which is the fried chicken. You guys are staring at this like it's the Rosetta Stone, like the truth is in there. It's just fried chicken. Right? Does your chicken not look like that? No, that's all right. So this is how this would work in a bash script, a traditional workflow. Let's take a look at how Snakemake would handle this. So first off, instead of a bash script, Snakemake uses something called a snake file. A snake file is a text file that defines the workflow. It uses a very simple markup to define rules, and each rule describes how to create output files from input files. Now, these 3 rules mirror the bash script, and in fact, this looks like kind of a wordy version of the bash script we just saw. But we're not done, because in addition, Snakemake also declares all the input files and all the output files for each rule. So instead of having a single input for the workflow and a single output for the workflow, we now have inputs for each rule and outputs for each rule. That becomes very important because in this way, the snake file defines the dependencies for all the input files and all the output files, and it so defines the relationships that connect the different rules. Okay, that's what the snake file does. So now we can talk about what Snakemake as a whole does. So Snakemake is a program, happens to be a Python program, that interprets the snake file against the files in the file system, and then it executes the rules as necessary to produce the output that you asked for. So when you execute Snakemake, like you see on the right, you just invoke Snakemake, and in your snake file, you said you wanted fried chicken, so Snakemake figures out, well, to get a fried chicken, I have to execute the fry rule, and before that, I have to execute the bread rule, and before that, I have to execute the marinate rule. And that pattern, that declarative pattern, it's very, very powerful because I never have to say, I need to execute the bread or I need to execute the marinate. I just tell it what I want to end up with, and Snakemake figures out what it has to do because it can, because you already expressed that in your snake file. That declarative pattern also has a couple of really nice consequences. For one, it's really easy to extend Snakemake to handling new inputs, variations on a theme. So we can start with getting buttermilk fried chicken, but it's very trivial to change that snake file to then extend it so that we can also get a lemon herb marinated fried fish. It's very, very trivial, and it doesn't change the structure of your snake file very much at all. Another thing is that Snakemake is very durable, and I mean durable in the sense of a database is durable. It crashes well. I have never gotten Snakemake per se to crash, but a lot of the tools that I invoke, bioinformatic tools, crash all the time. They are very flaky. So when Snakemake crashes, it's going to delete any files that were not complete. In this way, whenever Snakemake stops, if a rule was executed, you know it succeeded. And if it didn't succeed, it was as if the rule was never run. Now, that's really nice right out of the gate, but it also means that once I go in there and I fix the problem, to restart Snakemake, I just type Snakemake again, and it picks up exactly where it left off, because it knows what it needs to do. And in fact, at any point, I can ask Snakemake, what have you done and what's left to do? And this diagram here on the right was something that I generated by typing Snakemake with a flag, and it just generated that diagram. Another thing that's really nice about Snakemake is that it's computationally efficient. If you consider a traditional pipeline like the shell script that we looked at first, and let's say that we had a set of inputs which I'll call input A, and that workflow had 4 different tasks. Each of those shaded areas is a task. Some of those tasks are going to be quick, like the first task, but some of them are going to take a little bit longer, like the second task. Also, each of these tasks has a certain resource footprint. It needs a lot of memory or it needs a little memory. Well, when you put it all together and you think about, well, how much time am I going to need to execute this? You have to sum up the lengths of all the tasks. But then when you think of how much resource do I need to execute this, you have to take the maximum width of any of the tasks. Now, what that creates in this diagram is white space. What it creates in your life is waste. That's wasted time, and it's wasted compute resources. And it gets worse if you have to execute a series of inputs, which we often do. So Snakemake, because it understands the relationship of all the rules and the relationship of all the inputs and outputs, it knows how to parallelize all the jobs, and it does a fantastic job and a very efficient job of parallelizing all of your rules. Also, it understands the idea of resource constraints so that you can do that intelligently, and it can commit only the resources that you need. It's always faster, and it's always more efficient. This is really nice. Snakemake is portable. So if I want to run it on my workstation, I run Snakemake. If I want to run it somewhere else, I just add a flag, and it's going to work. It runs on all the operating systems, and it's compliant with Docker and Conda. So in general, I could build out something that did something as well as Snakemake. But the truth of the matter is I really just want to focus on the data flow. And Snakemake enables me to focus on the data flow and leave all of those mechanics and meta intelligence to the side and attend to them only if I need to. So I like Snakemake. If it's interesting to you, I'd be happy to talk with you about it. It's not limited to simple pipelines. And I'd be happy to answer any questions you have on Snakemake. Thank you.
Can I get a quick pro-con versus plain make?
Okay, a quick pro-con versus plain make. So Snakemake is spiritually built on top of Make. I mean, it's not actually implemented on top of Make, but it was inspired by Make. And so Make is your go-to, it's a go-to tool if you're doing a lot of C work. Really, if anything. But so what Snakemake does that Make doesn't do, there's actually three things. One is that the wildcarding system in Snakemake is a lot more intuitive than it is in Make. So it's really easy to figure out what's going on. Second thing is that with Snakemake, you can declare multiple outputs. Okay. The third thing is that Snakemake has that job submission built in. So if you want something to work on your laptop and then you want to drop it onto a Slurm cluster, you don't have to change your Snake file at all, which is really sweet. The other thing is that I lied a little bit. When I said that the Snake file was a text file, it looks like a text file, but it's actually a Python file. So anything you can express in Python, you can teach Snakemake how to do. And that's pretty powerful. Yeah.
Was there a question on the left there? No? Is it up here?
Does Snakemake also draw your computational graph for you or your workflow graph for you?
Yeah, the question is, does Snakemake draw this job graph? And it does. This is generated by Snakemake. Yep.
So let's thank Chris again.
Thank you.
So next up, we have Maureen Metzger. She's going to be talking to us about Introduction to the fast.ai Deep Learning Library for Python.
Great, thanks, Don. So this is aimed more at those of you who are maybe newer to the whole machine learning, deep learning data space here, which I am relatively speaking. So though I'm a PhD in health services research, it was just a couple years ago that I started learning Python. And about 6 months ago that I started, embarked on a deep learning course, which I think is like super cool. Never thought I would have anything to do with deep learning because it's not really in my, a lot in my area, which is healthcare. But I liked it, so I thought I would just share some of that today. I kind of lied to Sean. I told him I was going to talk about the deep learning library, but I'm also going to talk about the MOOC, which is where it came from. So, and my affiliations, I'm with the U.S. Department of Veterans Affairs for the next 8 days, after which I'll be moving to Jewel Health. Okay. So where's fast.ai come from and kind of what's the idea? So this is the brainchild of Jeremy Howard, who some of you may know from the Kaggle competitions. He was CEO for a while. He also was started up a company called Analytic that did early applications of deep learning to medicine, so radiological images and reading those. He is now moved over to teaching. He founded fast.ia as a way to kind of democratize the education of deep learning and people, making it more accessible to people. So what he has is both kind of an in-person course, and then whenever he runs the in-person course, he then packages it up as a MOOC afterwards and puts it completely online. So it's a couple of 7-week courses that he offers. I'm doing the live virtual versions, but the online versions are great too. Some of the things that are great about it: number one, free. Free is good. Number two, there's a large community of learners from all over the world that are participating in it. So you've always got a couple, 300 people there learning alongside you and there to answer questions on the forums and very willing to share their knowledge, which is a great resource when you're someone like me who always likes having someone to ask a question of. Okay. So a little bit more about MOOC, and then I'll talk a little bit about the library. So starts off with some basic convolutional neural networks, image classification, moves on to some NLP with recurrent neural networks, with a real emphasis on applying things first, kind of seeing how things work first, and then popping open the hood and looking underneath and saying, let's look at the code, let's look at the algorithms, what's going on here to help people understand more what's behind the whole deep learning thing and what makes a neural network different from, say, a typical machine learning kind of process. Very big emphasis on practical things, so less, although he does this time talk a little bit more about, how you read papers that are out in the literature and some of the new things that are coming out. Very much emphasis on practical things, just, hyperparameter tuning and best practices around things like that. But also the idea of transfer learning, so transfer learning being the idea that somebody's already trained a network on something like a large database of images, and that you then take what they've done, take the parameters that they've learned, and then just apply it to your own problem by making tweaks to what they're doing. So you may have a model that's been trained on thousands of images of all kinds of different animals, and then you turn around and you say, well, I'm just interested in distinguishing a dog from a cat, so I'll take this network, I'll chop off the end of it, and then I'll just use it, retrain it a little bit to distinguish dogs from cats. So a lot of success in doing that. It's not a, well, depending. Some people don't think they think it's cheating. It's kind of the too easy way to do it. But, so it's kind of nice because he's trying to make it accessible. It's not oriented towards people who have PhDs in math. It's oriented towards people who can understand an Excel file and see, you can apply that. You can say, I'm applying a convolutional filter here, and you can see the calculation right in the spreadsheet. So definitely trying to make it, again, accessible to those of us who took calculus a long, long time ago. So along with this, he's kind of built up a library of helpers, tools for both machine learning and for deep learning. It's kind of additional layers of abstraction that are built on top of scikit-learn for the machine learning and PyTorch for the deep learning, also Spacey for NLP applications. So he's kind of, adding some stuff around the edges. It just makes it a little easier to work with. So there's, that said, he's kind of not dumbing it down in that he seems to be pretty on top of the literature. So there's some neat things that he has to offer, like new methods for quick ways to find a learning rate that's a pretty good learning rate to use for training your network, different things like that. Also lots of like pre-processing tools, data augmentation tools, tools for pre-processing text or time series data, other structured data, which he also likes to feed into neural networks. So for someone who's kind of coming into this and pretty much interested more in application rather than like developing your own algorithm or, getting a PhD in this type of field, it's a nice set of tools to have, very accessible, great community of people, and it's kind of fun to be able to train a network to 99.1% accuracy in 3 lines of code. So I present you with just fast AI, and if you're interested in the MOOC or any information on that, feel free to just tell me down afterwards.
Thank you. Question for Maureen.
So you just go to fast.ai.
Yeah, fast.ai will get you to their blog space, and there's a link to the MOOC on there. Yep.
Other questions?
Have you tried some of the other libraries that it's like based on? Is this just like much easier to use or a little easier to use? use, or how was the user experience?
So I couldn't really make it through the PyTorch documentation on my own. So for me, it was a much enhanced experience to do this. For some of the others, might not be as much of a value add in terms of Spacey or some of the other libraries that might be a little more user friendly. But I think for the kind of the guts of the deep learning, for someone like me at least, it was super helpful.
Great. Let's thank Maureen again. All right, our final speaker for tonight is Jeremy McMinis, and he's going to be talking to us about an Airflow ETL on Amazon, AWS.
Thanks, Sean. So my name is Jeremy, and I'm kind of a data engineer and a data scientist. And so like the part that I'm going to talk to you about today is kind of, there are things that happen. I think this is a slideshow, so give me a second. I don't want to do a slideshow. So the things that I'm going to talk to you today are some of the things that happen before you get to do some of the data science that you like to do. And so, as a startup guy, the way that this works is that I'll go somewhere and like you'll have like a database that lives somewhere that your application uses. People start asking you questions to do analytics on it, and you'll have to get that data somewhere you can make it useful. So what I'm going to show you is Apache Airflow and how you can use it to do an ETL process, which is extract, transform, and load on an AWS platform. So the data team needs data. You can't do what you want to do, what they paid you to bring here, and you just can't do it unless somebody gets you the data. And so all the good stuff is trapped in your app's production database. So what we're going to do is we're going to try to get it out without crashing the app and without getting fired. So the problems typically are that your application database is really optimized for doing transactional things, right? So you want to go and update rows. Whereas what we need to do is we need to do analytics on it. So we need columns, right? Maybe you don't have a read clone. Maybe you do have a read clone, but it's a wimpy one. So as soon as you start querying it, everything just stops. You can't pull your data straight off production because somebody's going to call you and tell you that you're in trouble. So the solution is most engineering teams will take a daily backup of their production database. So after that happens, it's nobody's. You can take it, you can spin it up, and then you can use that data in order to pull it somewhere else and do your analytics. So we're going to restore the snapshot each day. We're going to load the data from it into S3, where you keep your files, copy it to Redshift, and we're going to do all this using Airflow. So these are the different pieces that I'm going to show you. I'm going to show you a little bit about Airflow, a little bit about AWS data ecosystem, how the data gets flowed, and then just a little bit of code. So is anybody here on AWS? Is anybody familiar with the, okay, great, yeah. So RDS is the relational database service. It's a hosted version of the databases you know and love. My favorite flavor is Postgres, but if you love another flavor, you could use it too. Redshift is a column store. It speaks about the same language as Postgres does, except for it's built to do analytics. It takes some tuning. It's not too bad to learn. If you're interested, we can talk about it. Apache Airflow is a project that was started at Airbnb several years ago. It was really one of the first kind of data engineering projects that I'm aware of outside of the kind of Hadoop ecosystem. So it's all like a Python 2.7 project. It provides you a bunch of building blocks, operators and tasks that are easy to extend in Python, and you use those to build directed acyclic graphs. So very similar to the picture that you have for Snakemake. The very nice things about it from an engineering perspective is it gives you visibility. If something goes wrong, you get an email or a Slack message. You can go back and you can look at your audit logs. You can see the history of what's been happening, how long it's been taking, really understand what your data flow is doing. So here in the picture on the top right, I have the picture of a DAG. These can be simple or complex. Just a series of steps that it goes through. Here's a piece of monitoring. This is mine. So they're all green. Then this is the kind of historical set of the different DAGs that run. Sometimes they fail. That turns red. You can see them. So this is the kind of basic data flow if you're very early stage in a startup and all you want to do is every day get your data out. So every morning, RDS is going to take a snapshot. It's going to get put on the AWS. Airflow is going to poll until that snapshot is available. You're going to restore it. You're going to take that RDS instance and you're going to copy all of the data to disk. When you copy it to disk, one of the really nice things that you can do is you can select things off of the tables. You can do joins, you can do functions, anything that you can do in Postgres easily, this is the time to do it because it's not so easy once it gets to Redshift. Always beware of changing schema. It'll keep you up at night. Then from Airflow, what you'll do is you send that data to S3. When it's on S3, you can split it into chunks. Then from S3, you copy it into Redshift. Redshift, there's some nice things that you can do whenever you're moving it over, like analyzing and compressing the data. Again, beware of changing schema. And this is just kind of an example DAG. It's a little bit of code here. On the right-hand side, we have the DAG definition. So your directed acyclic graph has a series of steps. This bottom picture right here, the DAG flow, it's just a simple linear set of steps. So you check for a snapshot, you delete the old rollover database, you wait for the new rollover to be available, you restore the snapshot, you modify it by applying any modifications that you need, you reboot the database, wait until it's ready, and then you continue downstream. This is a task, it's written in Python, you can read it, it's very straightforward, and the very middle of it, there's a get recent snapshots, that's a Boto call, and that's the meat of it. The rest of it is just error handling and like telling you that you need to wait a little bit longer. And that's it. So I hope to provide a template or code sample soon. I know that this is kind of more on the data science and the data engineering side, but if you're interested in it, then this is like a pretty clean framework in order to do ETL.
Thank you. Question? Let's start in the back with Jeff.
When you're copying it to disk, where is it going?
So Airflow has a couple of different ways that you can do this. One of them is that you can have like a Mesos like cluster. You can use Kubernetes, but it's a local disk. You can do it on node if you just have small amounts of data. You can handle concurrency and all those other things through the configuration in order to not overwhelm your disk.
Ben?
Can you go back to your picture, your flow diagram?
This one?
The 5 steps.
Oh, this one.
There's a lot of moving data between, like I said, presumably your OLTP database is that first RDS database, is that right?
Yes, this is the app production database, and you have a daily snapshot that gets stored in the AWS cloud that you then restore. AWS does that automatically.
I see. So what is it? Why do you have to send stuff to S3? Why can't you go right from Airflow into Redshift?
So Redshift, there's 2 ways that you can load data. One of them is by like values, but the other way is using a CSV. And so the CSV for Redshift is built to accept data off of S3. This is a requirement for using Redshift.
Alternatively, you'd have to do insert statements into Redshift, which would be slow.
Bad.
Okay. Got it. That's cool.
Is Redshift built on top of Postgres?
So I believe it was like Postgres 8.3, somewhere around there. Redshift forked. So there was a company that built a multi-processing like kind of column store on top of Postgres, and then got bought, and that's why they're so similar. Yeah.
In the back.
So why can't we go directly from RDS to Redshift? There's clearly something I missed there.
So I don't know how to do that. So what you can do like a PG dump. You can. So you have okay. Just a minute.
So I think you just answered my question. There's no translation layer from RDS. So Airflow, the reason for Airflow is it's a translation layer from RDS to Redshift.
No. You have to put data in S3 to get it in Redshift. Airflow provides scheduling, monitoring. If I just had a direct command that I could issue to move data from RDS to Redshift, I would do it in a heartbeat. And I would schedule it with Airflow, and Airflow would tell me when it failed and send me an email.
But I also use Airflow to do like a small bit of analytics if I'm making the same plot every day. The same snapshot.
Yes, so I have part of the work of doing a SaaS company is that you have to build user sessions. And every morning I have an Airflow job that goes in and runs a SQL query on top of my database in order to sessionize all of the new user data.
Why?
So, I think just to be respectful, right? So maybe with that, not only should we thank Jeremy, we should also thank William, Chris, and Maureen for giving such wonderful talks today. Thank you. And please stick around, interact, ask questions to our speakers.